There are many questions about our universe that stimulate the imagination of each of us. Above all, what is the universe made of? This question seems to be the most simple to answer because, after all, if we look in our solar system, for instance, we see planets, we see the sun. If we go outside the solar system, we see many stars. Stars are made of the same elements we are made of, for instance, hydrogen atom. On the other side, all cosmological evidence seem to indicate that only about 5% or even less of the universe is made of the same content of planets and stars. The large majority of the energy density of the universe, about 70%, is in a form of an unknown fluid that goes under the name of dark energy. The remaining 25% is made of another component, which is called dark matter. Dark matter is called dark because, of course, we don't know what it is, and is also called dark because dark matter does not interact with light, it does not emit light, and in that sense it is called dark. So we have many observational evidences why dark matter does exist. Let me mention a few of them. When we look at stars, how the stars are orbiting around the center of our galaxy, gravity becomes weaker and weaker when we go to larger and larger distance. So you would expect that the objects which are gravitating around the center of something which is very massive will orbit with a velocity which is smaller and smaller. On the contrary, when we look at these stars or galaxies orbiting around the center, what happens is that the velocity does not give any sign of decreasing. It looks like, let me give you an analogy, you're having your breakfast and suddenly your cat jumps on the table and your piece of bread with Nutella or butter falls down, and instead of falling down on the ground, it stops or it goes slowly, never reaches the ground. So this is surprising because, of course, it goes against all the laws of nature that we know. The second evidence is the so-called weak lensing effect. Einstein told us that space and time are dynamical quantities. They are not rigid, as everybody learns in the high schools. So Einstein told us that, in fact, gravity is the effect of the curvature of this bending of this space-time. So the same happens to light. When light propagates in the universe, it feels the curvature of space and time created by objects which are inside our universe, and therefore the trajectory is not a straight line, but it will be curved. So when we observe a galaxy which is very far from us, we receive light from the galaxy, and what happens is that we don't see the galaxy as it is, but we see that its shape is deformed, or sometimes we see even one or more images of the galaxy itself, of the same galaxies. Now, what is the reason of this curvature, of this bending that is changing the trajectory of the light? The reason is the presence of dark matter. We physicists believe that, in fact, this dark matter is a particle, and the density is very small. You should have at least 10 bottles of 1 liter to find at least one dark matter particle. So how do we probe this hypothesis that the dark matter is, in fact, a particle? Underground detectors try to catch a particle of dark matter which, by chance, will eat the matter which is inside these detectors. These experiments are not very easy to perform because, of course, this event is very rare. You expect, roughly speaking, 1 event per kilogram of your detector per year, or even less. The second way to detect dark matter is to go to space. The idea is that sometimes the particles of dark matter which are in space meet each other and they annihilate, they encounter and they produce sometimes light, they produce electrons, they can produce other particles that we know and that we can detect. The third way is, in fact, something very close to where I'm speaking from. It's in Geneva, it's the Large Hadron Collider. So the idea there is to make a bunch of protons smash. The idea is to transform the energy of these protons into masses of particles that we want to produce. The idea there is that time to time, one of these particles that are converted from the energy of the protons is a dark matter particle. In order to discover what dark matter particle is, we need to be very lucky. On the other side, we also have to be ready and to accept the idea, which is part of science after all, that we will never know what it is.